see. Great. So welcome everybody to another exciting edition of the Bionics monthly meeting. We have these every month. It's the first Friday of the month. And today we are lucky to have Alberto Nevada with us, sharing some of his work. He's been working on Bionic related projects for a number of years. Just a little bit of quick background. He's been working for 25 years with R&D and software and embedded real-time system engineering. I know you've been involved with one of the main chapters in Italy, and specifically focusing on youth children born with agenesis and early amputation, and having some experiences working with your family with that. So really being committed to developing options and building community. At the last post, I saw you had 400 people in the association that you helped to start, which is quite significant. So why don't I pass it to you if you want to give a more in-depth bio of your experiences and take it away.
Okay, thank you, Ben. So yes, I started my work in this kind of activities as a consequence of my personal events. I mean, my daughter lost her hand when she was aged 2, and since then I started to think how I can figure out the best future for her. And luckily, I met some other parents with the same purpose, and this ended in the creation of our association of families. You just mentioned it. We have several hundreds of members, and lots of them are parents with children with this kind of problems, so with limb difference problems. And we are trying to work together to help the families, support them, but also to try to figure out how we can make something more in order to facilitate their growth, and we hope allowing the creation of new facilities, devices, prosthetics, and what's needed to make their life better. And in this, I have also a lot of experience, as my working area is telecommunication. So looking around, I've seen there were some projects trying to exploit, to use electronics in this kind of solutions. On the other side, we see that there are commercial products that are really expensive and very far from the possibilities of the majority of the families and the people with this kind of problem. And even there is also a great discussion about how this kind of solution, how much they are useful, if they can effectively be of help in everyday life. In general, my idea is that everything is an opportunity, and then it must depend of the user according to its habits, its his approach to everyday life, what she can do with these systems. But it will be, I think, in general interesting try to push to have low-cost solutions and to bring this kind of solutions to allow more people to get access to these solutions in order to give them the possibility. Then it's a personal choice to use or not them. And this is one of the mission of our association, of the Energy Family Project Association, to facilitate the access to this kind of technologies. And in this direction, I tried to get value from my experience and from my knowledge. So I was just mentioning in the briefing a few minutes ago before to start the live session. 1 year ago, I shared some ideas about the possibility to create a kind of bionic platform that could be used by volunteers. And after one of the last meeting, it was May or July, I think, I got the idea to collect some open source projects in internet in general in the community, and to try to create some get inspired by them and try to create something that goes in the direction that I just mentioned. So I talked in our association. We assessed some funds to make this kind of activity, and I would say in the last 2 or 3 months we started to work in this direction. Start to build a first set of electronics components that can be used to assemble, to create some something more complex that goes in this direction. I've prepared a presentation on this. We can go through this presentation. The idea, the main idea is to share the project, how we are working, and hopefully to get also some suggestions, some help, some contribute from the community, because in general the objectives are not easy to achieve. We can I'm quite sure we will do our best to try to make as much as we can, but obviously if it becomes something that is accepted and driven by the community, it will get much more we will get a boost in this activity, and we can get a much better result.
That sounds great. So Alberto, if you want to share your presentation, I know just to fill in a couple of folks that are just arriving, Alberto is working with an association of about 400 members, several hundred members, family members, supporting lots of children, but other family members with limb difference, and looking to make the exploration into bionics a little bit easier, having a hardware platform that makes the decisions more clear.
Yes, I've seen the new members update to the conference. They are Francesca and Alessandro are both from our community, are true proud members of our community. Okay, thanks also to them for participating. I'm going to start the presentation. Can you see the presentation?
Yes.
Okay. Yep. So very quickly, which one is the idea behind this project? The idea is to develop a standard open source platform that can abstract a generic architecture for creating bionic, or I would say electronic controlled device, because bionic it's a big word, and maybe could be something that we can go close at the end of this project. And from a practical point of view, it could be seen as a set of libraries and tools and portion of software that can facilitate the development of this kind of device. The idea was also to develop something that can potentially be implemented on different hardware platforms in order to allow more flexibility and to give to the users the possibility to choose their appropriate, the most appropriate hardware solution for them. In general, as I said, in the last months, we focused on the creation of a general purpose hardware modules that can be combined in some way to achieve some task. After we will see some details on this, and this is one of the hot topics on which we are working. The reason to do this can be seen in the fact that there are few solutions that try to use electronics to give more functionalities to devices. They seem more or less some kind of specific implementation made for a recipient or for a specific task, and then it is they are shared in the community, but there is in general a difficult. It's not easy to adapt or to reuse these models in other environment and situations.
Which one I'm committed to help it.
Sorry?
I muted Lawrence. There's just a little bit of background noise, and okay. Lawrence, you can always unmute when you're.
Okay. And the electronics, the solutions that try to use some electronics doesn't seem to exploit much of the what the technology today give us. If we consider the complexity of some kind of electronic device that we have, definitely we don't have the same functionalities and complexity on the other side. So the hope is that trying to develop this kind of platform, we would facilitate the building of a vertical solution on top of it. Single activities could potentially be reusable, so an improvement made by one volunteer or a group or a research group can be reused in other by others, and it can help to hide most of the complexity that there is in software and the electronic itself. I was thinking to for example, the Arduino. There are lots of the Arduino platform. There are lots of boards and lots of libraries. People with not great skill in software development can use this building block to try to develop something that often is quite complex, and that will be really difficult to achieve starting from scratch. And so how to reach this result? We have identified mainly two paths. One is to work on the software side to develop a set of libraries and reusable code that can be used to compose this kind of solution. Another possible line of development will be the development of a specific hardware platform that remains still in some way general purpose in order to be composed to do specific tasks. In softwares, in general, this is what we presented last year in the Bionic meeting. In software, they can be organized, the software packages can be organized in sensor actuators, everything that is related to communication and algorithm and signal processing. That is one of the area where maybe we can have one of the great improvements, getting also the benefits of the progress in the machine learning and this kind of technologies. And okay, this is just a representation of a possible architecture. So the platform is what stays on top and can get benefits of the already done building blocks. Here we have more details. So for example, for a sensor, we can have EMG sensor, pressure sensor, or something that can decode the gestures and motors. There could be different kind of motors, actuators, and so on. And the same for the communication. This is an important part because if we have facilities to integrate this kind of solution, an embedded solution with host, we can get benefits, at least during the development. We can get benefits of this kind of integration. Let's think, for example, to a solution that allows us to easily capture the EMG signals and store locally or even in the cloud. If we have several of these tools, we can quickly create a data set of this information and try to develop machine learning solutions using that can try to decode the information and apply, for example, neural networks and this kind of deep learning, this kind of technologies to try to control an electronic device. So an end, in order to figure out which one is the intent, which one is the best wrap that the user wants at in a specific moment. And okay, this is what we have already said. And this is a general overview. So on top we have software, on the lower side. On the lower side, we can have what are already available solutions in terms of products, sensors, motors, linear actuators, and even controlling boards. But this was the addition we made in the last month. We can have also some specific boards. So we're going to focus on this specific part on the hardware modules that we are trying to develop. The basic idea is to try also here to reuse some elements and to in order to maximize the result with the minimum effort. So what we thought was that it could be possible to develop some specific boards with a small footprint, each of this one dedicated to a task that can be in some way interconnected by means of a communication bus. So in that way we can pack them, connect them to get different functionalities. And we moved in this direction and started to define as a kind of minimum requirements in terms of hardware for the communication bus. And this is what we defined to be the minimum set needed to do this kind of work. So there are a set of signals that are quite common in more or less all the available processors in the market. And the idea is to create boards that can eventually use any of these available CPU, MCU in the market, but that can exposes a specific interface. In particular, we started to work on 3 different boards. One is the board with ESP32 processor. Is a 32-bit processor with 250 megahertz dual-core CPU, so it's quite potent, has enough potence to power computing potence to be used, for example, to run the TensorFlow library, that is the compact version of the machine learning library developed by Google. And this board supports USB external power in order to be to get the power source from battery charger or an external element, or can get even the power from the bus. As some sorry. The idea is that this board exposes some interfaces to control peripherals, and as said, can have also an external, can be also powered by an external source. We had started also to develop 2 other boards. One is the TNC4 4.0 board, and the other was using the particle photon. The last one was in particular a board that we used in the past to develop a prototype. So we were already familiar to use this kind of board. And the other is a Chinese product, but with a great computing power. Unfortunately, both this is a period where there is also in the electronics and in components there are lots of problems to get them on the markets, and we focused specifically on the ESP32 because it is one of the it is a product that has a good availability on the market, so it's the one that can be practically built in a near future. For the other, maybe can be available again on the market in months or even in 1 year, and the time frame becomes too long. For which regards this kind of board, the ESP32 is quite complete. We have started design review. I think I added. Oh, sorry. Okay, I've not added a picture of this specific picture of this board, but its footprint is really small. It is 3 centimeters for 3.6 or 3.7 centimeters. I'm talking about the one on the right. So it has a very small reduced footprint that allows, for example, to put this kind of board on the external side of a device, and we are trying to follow the same approach also for the other boards. Okay, this is some detail on what can which one are the option for the to power the board. It can get powers from an external source or from USB or from the bus. At the same time, when it is powered by an external source, it can provide power to other boards connected on the bus. And the second module we are working on is, okay, here is, this is the footprint and the details, and these are the details of the board. As I said, it's quite a very small board with good capabilities, dual core processor, 2 megabytes of RAM, 8 of flash memory. It has also Wi-Fi and Bluetooth and several peripherals. It supports Arduino, TensorFlow Lite, and for the development also the platform I/O. And I hope in the next few weeks to complete the review for this board and to start the process to build a small set of this board in order to start using them. The other board is an EMG board. The idea of this board came from one of the past meeting we had here when Bionic presented their solution, and I just I've seen in this solution the implementation of one of the ideas that I had in the past. So the possibility to have several sensors for EMG signals. In general, we have usually 2 electrodes on the arm, and this allows a very simple control of myoelectric prosthetic arm. I was thinking of a way to increase the number of the electrodes in order to increase the information captured from the residual muscles. And when I've seen these projects, I understood that it was feasible in some way. So I start to work in this direction and to develop the schematics for this board. It is based on a TI, a Texas Instruments sensor that is used also for ECG, and that can work for EMG signal acquisition. And they can work also in parallel. So several of them can work in parallel. And each of the ADS 1928 is a component that is able to capture 8 signals, 8 to handle 8 electrodes. And several of them can work in parallel. So in theory, we can have 16, 24, and even more acquisition points. The problem is try to understand how to get this source of signals, to put this source of signals on the skin, on the residual, on the stump, on the residual arm. And maybe one of the points that could be investigated is, for example, to study for to try to get benefits from the studies from wearable devices, and what is done in this field. And this is still a point that needs to be developed, but my idea is that if we have as much more information we have from the residual arm, and as much more information we are able to process, in that way we can better control, if we are able to understand this information, to decode this information with some mean, we can then try to identify more intents, more actions that can be done by devices. So we can get more possibilities. Going back to what I was saying at the beginning, this gives an opportunity for sure for students to make some study on this kind of solution, and we hope that after that we can have some fallbacks for real users. The last board is the main board. It can the idea is that this board can handle, can generate several sources in terms of power for motors, for example, and that can be the board that feeds energy to all the elements. And even this board is itself modular, where we thought that in order to achieve the maximum of the flexibility, we thought to the possibility to plug different modules, so that can be suitable to control linear actuators or motors with encoder to get information on the position, or other kind of elements. And in this case, there are still some details that need to be defined, some technical details, for example, which one is the best way to handle the power for the motor modules. Each option has its pro and its cons. Having everything on the module will make the single module more complex, and in the other case we can have a better control and simpler modules. But we are still working on this. And here is an example of how modules can be interconnected. For example, we can have an element that makes the acquisition of the EMG signals on the lower, the one in the lower part of the slide, that is connected to another two modules, one controlling board and the one with motors that in this case can control just two linear actuators. Here is another example of possible application. I mentioned it just a little bit before. So we can have an acquisition board that get EMG signals, and then the signals are transmitted in real time to an host computer that stores or processes the information in order, for example, to evaluate which one are the best algorithm to extract the information from the acquired signal. This is another example where we have a pressure sensor, and in this case, one or two that are controlled by the pressure sensor. We talked more or less about a similar solution in one of the last meetings, I think, when we talked about the kinetic end controlled by the pressure sensor with in a previous presentation. At present time, we are in this one are the phases of the project. We are in the middle of the design, and we started design review for one of the boards. We are driving the activities in parallel on the several elements. And after that, I said we will start prototyping for the boards, and then we will focus on the validation. The activity is, even if we started a couple of months ago, the activity is taking a lot of times for the fact that even when a design is complete, we found that components were not available, and we had to restart, rearrange the design, and try substitute and to replace elements, and in order to be to find a reasonable solution in terms of availability of products, in order to not remain stuck in the prototyping phase. And a few words about the challenges behind this idea, and even the risks. Obviously, this makes sense. All this work will be valuable if we are able to make something that is accepted and is usable. So if deliverables are effectively used by the community, that will be volunteers to create ends, students to make some study and to try to build something more on these solutions, and so on. But one problem will be, as said, we are committed to build a small number of boards for validation and for development purpose, but for sure we are an association of families. So our focus is, we are not a manufacturing company, neither a commercial company. So the production of this solution, if they prove to be useful, is beyond our scope. But as the project is are open source, and it's quite easy to, starting from all this information, it's quite easy to for someone that has a little bit of experience with this kind of technology, it's quite easy to produce this kind of solution. We expect that maybe as happened for several breadboards and this kind of stuff, there could be even a way to get this kind of solution. One thing that I've not mentioned is that we are designing these boards keeping in mind the fact that they must be low cost. And so the challenge will be to remain below, or far below 100 euros for each of them. So to have, for example, the controlling board to 10 or 20 dollars at least, and not more, because in order to be even usable for hobbyists, for volunteers, they must be accessible in terms of cost. And the last challenge that we need, the challenge that we have, and the related risk, is the complexity. The project is quite complex. Hardware is just a part. Once done, we need to provide a small set of functionalities, software functionalities on top of them, in order to make them really usable. and it's a lot of work that needs to be done. And we have started with this work with the hope that sharing it as an open source solution will facilitate the acceptance and the usage by other people in the community in order to do a part of the work altogether. So basically, as we said, and this is also the reason we are here to talk about this, is that in our opinion, if we reach a collaborative approach, if we are able to get specific skills on in the community, but even outside the community, I'm talking with some university here in Italy in order to, we have started since a long time to discuss about collaborations and to have students that work on thesis and other and make some research activity on some shared project, and this could be a good project for this kind of activity. And that's all, more or less. I mean, I tried to expose. I hope I didn't get too deep in the details, in hardware details, because it's
Well, thank you, Alberto.
argument.
I do have a question. It's
Yes.
it's a big vision, and what I'm not clear about is whether this is valuable before the big vision is realized, because it is a challenging project, and to get to the end of this grand vision would take many people, many years, and one can't be confident that you'll ever get to the finish line. And so I'm wondering whether a reference implementation of one stack using your taxonomy might be a good way to begin.
Yeah, this is exactly what we want to do. I mean, this is the general project, but we are focusing also on specific boards because we have some specific target that will be a subset, obviously, of the overall project. But
it occurs to me that as you're doing it, you might be in a good position to public reviews of the boards, talking about whatever problems you found, fitting them into the framework, because you're going to, basically, it's a testing framework. You'll be running them all through the same challenges to see whether your high-level commands will cause them to do the things you expect them to do. And that offering reviews as you go might be a way of getting manufacturers to offer you samples that you can work with, and might also, and this is my main concern, increase the value of individual small steps.
Exactly.
Because my big concern here is that you've got the risk that you're going to spend a lot of time, you won't get to the end point, and it won't actually be useful to anyone. So thinking of ways of making incremental steps useful may be an important key to success.
Yes, absolutely. The approach will be incremental and an iterative process to try to deliver every time something new, additional, and to increase the value. This is what I do for my work, and I'm trying to put here the same kind of knowledge even in project management. But
Right. The challenge is that at work, you're paid to do it, and other people are required to pay attention to it. In an open source community, neither of those things are true. And so it's possible, you know, to spin off a grand vision that just doesn't match the community. Anyway, that's a caution. That's my caution to you.
yes.
Well, Alberto, I really appreciate you sharing your work because, as you said, getting community input in an open source community pivots on being able to share, and that's exactly what you're doing today. I'm curious if Lawrence has any insights. I know he's been working specifically on a project for his daughter, and I've seen some of the comments back and forth about electronics and the communications bus and some of the stuff that you've been looking at technology wise. Be great to see where you're at and if you have any insights.
This is a part that has had several changes in, even if we started a little bit more than 2 months ago. The idea is we didn't found a commercial solution, so we worked to have a connector that was as much small as possible, and that could be used with male and female stacked. So we just get the signal from one side and put them on the other side and use them in the board. This was the solution that we have identified. We changed it several times because the first idea was to use a very small connector. Its height was 0.6 millimeters, and it was too small in order to allow to put components on the board. So we had to change it. And at present time, we have identified the product that has a good availability on the market and that we think could work for this kind of project. But definitely is one element that must be carefully reviewed during the review. And it is also an area where, but in general, if there are suggestions or ideas from the community, this is what we want to discuss together in order to improve the design and to have a better result. I already shared on the group some ideas, for example, for sensors. I just mentioned it before. One of the problems is the density required to have so much electrodes on the skin, and I'm sure that there are groups that are working on something, and people, researchers in the.
Yeah, so I'm curious, Lawrence mentioned at the beginning that he had some updates. How is it going for your project, Lawrence?
Well, I'm coming from a little bit of a less professional angle, where even the word communication bus, I think it's like how everything's connected. So I'm not very educated. Like, this is my communications bus here, I think. Right here, I have my little Arduino, and I have everything soldered together, and then I've used these DuPont little things. So I was very happy to hear about Alberto's. It sounds a lot more organized than what I have. But I did make a little cover. See, it's kind of, I've got something which is a little bit functional, and now.
All right.
Hold on. Hopefully it works. Maybe the battery's running out. Huh? All of a sudden, it don't work.
I saw it. I
Yeah.
saw it move.
Well, it was working proportionally. It was working where you could kind of grab a little bit at a time. I don't know why it did that. I think it got stage fright. Anyway, maybe next month I'll have something a bit better.
The demo effect. We talked about the possibility to work to improve the software control of this solution. This is a side activity that we can do, hoping we can help to achieve a better control with this kind of device.
Yeah, one aspect is really like he was talking about EMG sensors, and one thing with what I've done is that the FSR is a little awkward to it. That to me, that's a challenge a little bit. Like with the original design with this kinetic, it was an armband with a little kind of piece of plastic that pushed into the FSR when the muscle was squeezed. But to me, that's a real area to figure out practically. Anyway, I thought it was wonderful what Alberto had. You know, what he's doing. It definitely makes sense to have a little hardware solutions that you can practically use and put together fairly quickly, and then you can experiment, you know, because that's kind of where I'm at, is I want to get it in the field. I want to get it used, and then I want feedback, because before that, it's just a lot of ideas. And I think that's kind of a little bit what John was saying, is that you invest huge amounts in your ideas, but then there's a practical reality of an amputee who has to implement them in their daily life for the work to be of any value, really.
On that note, I want to call your attention to a link that I've just repasted into the chat.
I see.
Yeah, I saw that.
Very good article, worth thinking about, and perhaps inviting that person to a future meeting.
Yes, it is an interesting article that could be deeply discussed, and I think need to be discussed in order to complete the picture.
Right. I'm afraid I have to go. But thank you very much, everybody. It's very interesting.
Great. Thanks for sharing today, Alberto. What we'll do is I will share your video in the Bionic space, and any follow-up and feedback and future discussions would be great. If you want to add a comment with your presentation, that would be awesome.
Okay, I will add the presentation in the shared space in the Google Drive, so that it can be available for everyone. And thank you for having given us the possibility to share this project and this idea. I hope it can be. I hope that we will be able to go on this, and to have some deliverables, and that it can be useful for the people in general. Thank you very much.
Wonderful. Thank you so much for your work. And we'll continue the conversation in the hub space. And again, thanks, Alberto. I've noticed a lot of comments following up on discussions about all the technical sides of different projects. Really helpful. So definitely keep going with your work, Lawrence and Alberto, and we'll follow up and see you guys next month.
Okay.
Thank you. Bye.
Bye.